Hi everyone. Today I thought maybe in this tutorial I'll try and explain about logistic regression problem that we have shared on the learning platform. So let's quickly look at it. So as I can see, it is in week 4, day 2. First thing is we need to understand what the problem statement is all about. So let's check that. As I can see, it's about liver patients and I can see that in an effort to reduce burden on doctors, the government has hired you as a data scientist to build a predictive machine learning model that would give an indicator whether a person would have liver problem or not. Okay, so basically we need to predict whether a particular individual has a liver problem or not if they come up with some bunch of variables. Let's say the variables that I'm talking about here are nothing but input features. Let's see the data in the first place. The data set has these set of data points. One thing is liver problem is equals to 1 implies individual is a liver patient. Liver problem is equals to 2 implies the individual is not a liver patient. So this is our target variable. And now let's see what are the input variables. So as we can see, age of the patient is an input variable, gender, total bilirubin, direct bilirubin, alkaline phosphate, and there are a bunch of other variables. And here comes our target variable, liver problem. So basically, how do we predict? So whenever a patient comes, they'll be giving us all this data, or at least the government would be getting all this data. And based on these data, we need to predict whether there is a liver problem or not for that particular patient, right? Okay, so this we should be pretty clear about. So we understood our problem statement that we need to predict whether a particular person has a liver problem or not. Okay, now we understood. Now that we understood the data set well, now that we understood what we need to do, let's get started with problem solving. So here, as we can see, a little bit of I think we have already given the steps to build your model, right? First thing is it is asking us to load necessary libraries and then load your data set and perform exploratory data analysis. And the third step is you need to fill missing values if there are any, separate input and target variables, and then split the data into test and train. Okay, let's do these 5 steps to begin with. Okay, let's get to our data set, to our Jupyter notebook. First thing what I would do is I would import all the libraries that are important for this data set or for solving this particular problem. Okay, I'm importing pandas, I'm importing numpy, I'm importing I'm basically loading scikit-learn, sklearn package, and other stuff. Okay, as you can see here, I'm also loading something called as label encoder. We'll discuss about it, what it is exactly going to do. And also we have we're importing logistic regression module. Why? Because the problem statement is to build a logistic regression. Okay, and logistic regression is used for classification problem. Again, what is classification? Classification, the name itself says that we need to classify a particular variable. Okay, as we spoke about spam, not spam in context to emails, right? Similarly, we spoke about fraud detection data set, where we were talking about whether a particular transaction is fraudulent or not. And here we are detecting whether an individual has liver problem or not. So it's a classification problem, clearly. Okay. And basically it is 0 or 1. In this case, it is 1 or 2. Okay. Now that's the reason we are loading logistic regression here. So first things first, let's load the data set. So we have the data set in raw GitHub file. So how we need to load the data set, we just need to load it using the pandas function. So pd.read csv and you give the file name. So let's load the data. Okay, I'm sorry, like there is an error. So I need to run this first. So this, we need to always read the errors. As we can see, name pd is not defined. Okay, that means that we didn't import pandas as pd. We didn't define pandas as pd. That's the reason I'm getting this error. Okay, what we need to do is we just need to run this first line of code. Wait for a few seconds. Yes, it is done. And now I'm going to the second line. It's done. I'm clicking on tab so that I move to the third line. I'm just checking the data info by giving the name of the data dot info. Let's look at the shape of the data set. It's pretty trivial. And now let's look at the head to check the first 5 rows of the data set. We can see age, gender, total, and there are a bunch of I think medical terminologies or biological terminologies here. It would be interesting to understand each of these terminologies because that might help you in problem solving. And now, okay, just to give you some heads up, I'm not gonna take you all through the exploratory data analysis in this particular problem. Okay, we will directly jump into data pre-processing and then directly jump into the problem solving bit. Okay, now let's look at here. I'm just like writing a piece of code to understand how many liver patients are there and how many are not. Okay, as we can see, one. Okay, let's just check. Liver patients, liver problem is equals to 1 implies individual is a liver patient. So as we can see, 1 implies liver patient, 2 implies the patients without liver problem. Now let's check how many null values are there in this particular variable, albin and globin ratio. Okay, now why do we even need to check that particular this thing? Because as we can see here, all the variables has 500 as count, whereas only albin and globin ratio has 496. That means that there is some issue with the data set. So let's check if there are any null values. And yes, there are 4 null values as we can see. So albin and globin ratio has NaN. Okay, so we have 4 null values. Now we also need to understand what is album and globin ratio, right? Either we can check the data here, or what we can do is we can also read about that particular variable. So I'm just going back to the problem to understand what is, okay, we didn't give the data description here. So let me go back, quickly look at this particular ratio. It is just a ratio, right? It might be somewhere in between 0 to 1 or maybe more. We don't know exactly, but it's just a ratio is what I could understand. So what can we do now? So either we can replace it with median, or we can even replace it with mean as well. So in this particular scenario, I'm just taking median as the filling value, but let's say we're going with mean. Okay, it is totally all right to go with mean. And we have run it. And this is the interesting part. Now, as we can see, as we see the data set, always remember one thing. Whenever we input something to the machine learning algorithms, we need to input in the form of numbers or numeric values. So as we read the data set, everything looks fine except for gender. Okay, so gender is in the form of string, female, male, and so on. So we need to convert them into a binary variable, or basically we need to do one hot encoding. So what we are trying to do in this particular step is converting male into 0 and female into 0 and male into 1. Okay, this particular function directly does that. And also in the past, what we have done is we have used lambda function. Okay, I'll just quickly show you the lambda function as well. As you can see, this is the first machine learning model that we have built. I'm sorry if it is if I'm digressing a little, but it will only help you. So in this particular case, we also have the same kind of problem statement where we need to change the variable name sex to a numeric value. That is either like, we need to encode this feature with 1 or 0, with male as 1 and female as 0. So here we have used lambda function. However, there are some good packages like this where for example, here we are calling L is equals to label encoder, and we are converting gender into the values of gender, that is male into 1 and female into 0, by using these 3 lines of code. Okay, now let's see how it looks like after running. Okay, as we can see, earlier gender was female, male, female, male. Now it got converted into 0, 1, 1, 1, so on. Okay, you may ask, why is it not the same? Of course, I mean, here we are only getting the null values of albin and globin. That's the reason you're only seeing 4 values, whereas here I'm checking the first 5 rows of the data set, so there is nothing to be confused. Okay, 0 means female, 1 means male. Okay, and now comes the exciting part, where we need to split the data set into train and test. And before even splitting the data set into train and test, we need to separate the variables into input variables and target variable. Okay, this is something that we have been discussing, and this is like the de facto thing in machine learning when we are using a Python. So the first thing is you need to separate your input and target variable. Okay, and then proceed with splitting your data into train and test. Okay, so first thing is, let's declare X as our input features, as we can see. Okay, in this particular piece of code, what we are trying to do is we are having all the features, all the columns of your data, except for liver problem. Okay, which is your target variable. This is the particular variable which you need to predict, right? So basically what this line of code does, it's, as you can see, liver data. Liver data is nothing but your data set name. Where did we declare this liver data? If we go scroll a little up, a little more up, here we can see that liver data is equals to, we have been reading the CSV file from the GitHub, right? So this is where we declared it as liver data. Now let's go a little more further. Yeah, now coming back, so X is equals to liver data dot drop liver problem. So we are dropping that particular column where liver problem is. Okay, we're just dropping that problem. That's it. And that's how, we get all the features in X. So X contains all the features except for liver problem. And now comes the Y, which is the target variable. And what we are trying to do in this particular line of code is we are creating a new variable called Y with only liver problem as its column or data. Okay, it will only contain liver problem, nothing else. Okay, now we have separated our input and target variable. Now what happens next is we need to split our data set into train and test. Okay, for this we can write this simple line of code. I think we already have this template in place. So what we are trying to do is we are defining test size as 0.2. That is nothing but our data set, our main data, will be split into 80-20, 80% test train and 20% test. So our model will train on the train data set, and then later we test it on the test data set to check its performance. Okay, and here random state. So we have been speaking about random state. Random state is used to so that we can reproduce our results anywhere in this world. Okay, you can use any random state, but ensure that you put it in your code, be it 101 or 42 or 52, whatever it is. Let's ensure it is there. Okay, and okay, I'm sorry, like, I haven't run the above lines of code, and that's the reason it is throwing this error. Okay, now that I have run this code, should be able to run this as well. Okay, now comes the coolest part. So building models is always easy, right? So let's build the model. So first thing is, we identified it as a classification problem, and also problem statement says that we need to build a logistic regression, right? So we declare what our model is here. So basically model is equals to logistic regression. Okay, and the first thing that we do is we try to train our model on the trained data set. So in order to do that, what we need to do is we need to call this particular function. Okay, model dot fit. In the parenthesis, you basically give your X train and Y train. Basically, you are putting your trained data set so that your model is trained. Okay, once this is done, so basically you will run both the lines of code, and yes, you were able to build your model now. And now what we try to do is we try to test our model on our test data set, right? So in order to do that, we need to call this particular function. Pred is equals to, you can call anything. It doesn't necessarily need to be pred, it can be anything else. Okay. Here, while training the model, you use the function model.fit, and while predicting the model, you use model.predict. Okay, again, where did model come from? We have declared it here. Instead of model, if you want to declare it as model 1 or model 2, or maybe I can also give my own name, Chanukya underscore model. You can do anything. Okay, but that same thing should be repeated here and also here, or wherever you call. Okay, just ensure that. I just need to run this particular code. It's done. And now that I have built the model, and also I have basically predicted the data, or basically have tested it. Now I need to evaluate it as well, right? I need to check how it is exactly working. In order to do that, I need to write one more piece of code, and for this I need to import some evaluation metrics. Here the evaluation metrics that we are using is a confusion matrix. Okay, and we are taking the true negative, false positive, false negative, true positive. In order to do that, we just write this particular line of code, confusion matrix. And as you can see here, okay, this is one of the important things that we need to know. Okay, y test is nothing but the true values. Ideally, if you expect this particular value to come as your output when you're training a model and testing it on the live environment, or when you're testing it in production, you would expect the values to be this. Of course, if you're getting that exact same values, then there might be some fishy, because your model can't be 100% accurate, or may not have any errors. Okay, we always try to predict, and often we end up having some differences with the original values, or with the true values. Okay, so that is something that we need to know. Y test is your true value, and pred is nothing but your predicted value. So obviously you need to compare your prediction with the actual value. Okay, to explain this further, I'll give a nice analogy. Let's imagine Okay, let's imagine let's talk about myself, right? Let's imagine my age is 27. Okay, this is the true value. However, I have built a model and it has predicted my age as 28. Okay, that is the prediction value of my model. That is nothing but pred. Okay, whereas the true value is nothing but 27 because my age is 27, right? So that is nothing but y test. Okay, now what we are trying to do in this particular step is we are trying to compare the differences between y test, which is the true value, against your predicted value. Okay, so that's what we are trying to do in this particular scenario. It's very simple, and yeah, we just run this particular piece of code and we try to get our confusion matrix. And not just that, what we can further do is we can also check our accuracy. Okay, again, accuracy, y test against your prediction. That is, y test is nothing but your true value. Okay, if my age is 27, that's what it should be here. And the predicted value should be the predicted value of your model. Okay, which might be 28 or 29 or whatever it is, whatever our prediction is. And sometimes while building the model, the prediction can be 100% true as well for certain cells. So it can be 27 too. I'm not getting into those details, but here again, we are testing on y test and prediction. That is true value and prediction. Okay, the prediction of your model. Let's check that. As we can see, it's 0.65. Okay, it's not, I don't know, I mean, I can't really comment on this accuracy. It's good to always optimize our model, so I won't get to those details right now. I think I was able to complete till step 8, maybe, I guess so. Okay, as we can see, predict the target variable for your own test data set in step 5 and check the model performance. Now use your model to predict whether a patient is ill or healthy based on some clinical and demographic features. Okay, now we need to predict it, right? And let's predict it. Okay, so for that to happen, we need to follow the submission guidelines. If I go to the submission guidelines, I'm given a new GitHub repository, GitHub file. So I just need to load that particular data set and predict my, basically I need to do new predictions, right? I need to get the predictions based on some variables that are already given. Okay, so right now let me just load this new test. Let me check what all there in this new test. So as I can see, age, gender, again I can see the same set of values, but the interesting thing is basically I'm not able to find our target variable. Our target variable is nothing but liver problem, right? Liver underscore problem. Our target variable is not present. Why? Because we need to predict that. Okay, so we need to technically predict it, right? And now comes the interesting part again, whenever we apply. So one quick thing here is we have already built a model. Now we need to reuse it again on this new data set. Okay, so whenever we are trying to reuse it on our data set, if we have done any pre-processing steps, we should again try to apply it on our test data as well. Remember, we have encoded our gender variable into 0 and 1, right? Male with 1 and female with 0. And remember, whenever we are applying any machine learning model, it will only take numerical values. So that's something that we need to remember. So as we can see, everything is in numeric. So that's not a problem except for gender. So what we need to do is we need to convert gender into, again, 0 and 1. on the new test data set, which is unseen. Okay, so let's do that. First thing is, let's convert gender into a binary variable, 1 or 0. Now it is done. And now comes the model prediction. Now comes the prediction, right? So we have already built a model. Our model name is model. Okay. And what we can do is we can create a new variable called as liver problem is equals to model dot predict. And now we need to give our feature list, right? So basically we already have a list of features with us, age, gender, and all, which we have loaded it in the form of test underscore new. Okay, so let's give that data here and run it. So after running it, we have been able to predict whether a particular individual has a liver problem or not on this data set, on test underscore new data set. Okay, we'll also get the predictions soon. Again, I just wanted to reiterate, go a little back and reiterate on this. So as we can see, first thing is we have trained the model on trained data set. Okay, and we have predicted our predictions on the test data set, right? As you can see, X test. And then while comparing the performance, we were comparing the performance on Y test and pred. Pred is nothing but your predictions. Y test is nothing but the true value. Okay. Similarly, here, as we go a little down further, what we are trying to do is liver problem is equals to model dot predict. Here we are giving our X test new. X test new is nothing but our input features. And live problem is nothing but a target variable, which we are trying to predict. Okay, just remember this particular thing. And yeah, so we are trying to predict liver problem. And inside this, we have given all the input features. Okay, and we are able to predict our target variable now. That's it. Okay, so it's that's how we need to we go about predicting our target variable. It's just model.predict, give your input features, and you'll get your target variable. Okay. And once you got your target variable, we need to download the prediction file as well. And for this, I think we have already given a help link like this, where we have given a code snippet on how to download in Jupyter Notebook and how to download when you're using Google Colab. So I've picked the code snippet that is useful for Jupyter Notebook. So as you can see here, I have created data frame with liver problem. And yeah, similarly, like, I use the rest of the code. Thanks a lot. I hope you are able to comprehend this, and happy learning.